Welcome to Linear Equations Level 3. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving the equation 6 plus c is equal to 56 minus 9c. Now in this equation, we've got unknowns on both sides, and the easiest thing to do is to keep the unknowns on the side on which we start with the most. Now on the left, we've got 1c, and on the right, we've got minus 9c's. So we're going to keep the c's on the left-hand side. And this means that we need to remove the minus 9c. And we do that by using its inverse, which is plus 9c. And we do the same to the left. Now the left-hand side becomes 6 plus 10c, and the right becomes 56, and the minus 9c and the plus 9c cancel out. Now going back to the left, we'd like to remove the 6, and this is a positive 6. So to remove it, we use its inverse, which is minus 6, and do the same on the right. The left becomes 10c, because the 6 and the minus 6 cancel out, and on the right, 56 minus 6 is 50. Finally, to remove the 10 on the left-hand side, which is multiplying c by 10, we use its inverse and divide by 10 on both sides. The times 10 and the divide by 10 on the left cancel out, leaving us with c, and on the right, 50 divided by 10 is 5. So our final answer to problem 1 is c is equal to 5. In problem 2, we're solving the equation minus 3 multiplied by 2 plus 5d is equal to 21. Now to start, we'd like to remove the minus 3 that's multiplying the bracket. And there are a couple of different ways we could do this, but the most common is to expand the bracket. So we're first going to multiply minus 3 by 2, which gives us minus 6. Then multiply minus 3 by 5d, which gives us minus 15d, and we still have an equal 21 on the other side. Now looking back at the left, we want to remove the minus 6, and we do this by using its inverse, which is plus 6, and do exactly the same on the right. On the left, the minus 6 and the plus 6 cancel out, leaving us with minus 15d, and on the right, 21 plus 6 is equal to 27. Finally, we want to remove the minus 15 from the left to leave d on its own, and the minus 15 is multiplying d by minus 15. So the inverse of multiplying by minus 15 is to divide by minus 15. And we do exactly the same on the right. So on the left, the times minus 15 and the divide by minus 15 cancel out, leaving us just with d. And on the right, 27 divided by minus 15 can just be written as minus 27 over 15. And it would be fine to leave our answer like this, but we can also simplify by dividing the top and bottom both by 3, and this gives us minus 9 over 5. That's our final answer to problem 2. In problem 3, we're solving the equation 2 multiplied by 3 minus 4r is equal to minus 3 multiplied by 2 plus r. Now since we have brackets on both sides of the equation, we can start by expanding these. So on the left, 2 times 3 is 6, and 2 times minus 4r is minus 8r. On the right, minus 3 times 2 is minus 6, and minus 3 times r is minus 3r. Now, since we have unknowns on both sides of the equation, the easiest thing to do is to keep them on the side on which we start with the most. Now, on the right-hand side, we have minus 3r, which is greater than minus 8r on the left. So we're going to keep our r's on the right-hand side, which means we want to remove the minus 8r from the left. And we can do this by using its inverse, which is plus 8r, and we do that to both sides. So the left just becomes 6 because the minus 8r and the plus 8r cancel out. And on the right, we have minus 6, and then minus 3r plus 8r gives us plus or positive 5r. Now looking at the right, we'd now like to remove the minus 6. And we can do this by using its inverse, which is plus 6, and do the same on the left. The left now becomes 12 because 6 plus 6 is 12, and the right just becomes 5r because the minus 6 and the plus 6 cancel out. Finally, we'd like to remove the 5 from in front of the r, and since that's multiplying r by 5, we use its inverse, which is to divide by 5. And we do exactly the same on the left-hand side. So on the right, the times 5 and the divide by 5 cancel out, which just leave us with r, and on the left, 12 divided by 5 can just be written as 12 over 5. So r equals 12 over 5 is our final answer to problem 3. In problem 4, we're solving the equation 4a plus 6, all divided by 5, is equal to 3a plus 10. Now the first thing we'd like to do is remove the fraction from the left-hand side. And so to remove the divide by 5, which is at the bottom of that fraction, we use its inverse and we multiply by 5. Now when we multiply an equation by 5, we need to multiply everything in it by 5. So here we need to multiply 3a by 5, and we also need to multiply 10 by 5. So on the left, the divide by 5 and the times by 5 cancel out, which just leaves us with 4a plus 6. And on the right, 3a times 5 is 15a, and 10 times 5 is 50. Now again, we have unknowns on both sides of the equation, and so the easiest thing to do is to keep them on the side where we start with the most, which is the right, where we have 15a. So we want to remove the 4a from the left, and since this is positive, we use its inverse, which is minus 4a, and do that to both sides. So on the left, we just have 6 because the plus 4a and the minus 4a cancel out, and on the right, 15a minus 4a is 11a, and we still have the plus 50. Now staying on the right, we want to remove the plus 50, so we use its inverse, which is minus 50, and we do exactly the same on the left-hand side. Now on the left, 6 minus 50 is minus 44, and on the right, when the plus 50 and the minus 50 cancel out, they just leave us with 11a. Finally, to remove the 11 in front of the a, which is multiplying the a by 11, we use its inverse and divide by 11, and do exactly the same on the left. Now on the left, minus 44 divided by 11 is minus 4. On the right, the times 11 and divide by 11 cancel out to leave us with a, and so a equals minus 4 is our final answer to problem 4.